So for this week, our focus will be on linear data structures. But before we go into that, let's talk a little bit about abstract data types and how are they related to data structures. Well, you may have had a introduction to this, but let's talk about it a little bit more to understand the future lessons in this lecture notebook better. So the abstract data type is a mathematical abstraction of a collection of objects and operations done on this subject. So as the name suggests, it's a data type. So for example, we have the integer data type, the float data type, the strings data type. So it's basically a construct. So for example, for the string data type, we have our own operations on the string. It has its own way of addition and uh, multiplication for Python, which is different to that of integers and characters. So the fact that the addition and the multiplication operations are different for these two data types means they are separate data types. So when we define an abstract data type, we usually talk about what do we uh, what are the attributes of this data type and what do we do with the data type. So it pretty much uh, it's pretty much has the same almost the same definition as a class, but it's a little bit more abstract because uh, a class will be more similar to what we call uh, it will be much more similar to what we call as data structures because our data structures is the specific implementation of an ADT, especially when we talk about computers and programming in general, because a abstract data type is a concept and our data structure is the actual implementation of that concept. So a class will most probably be more accurately represented or more accurately or more closely related to a data structure. Which is why actually for this part of the course, object-oriented programming, which deals a lot with classes, will be heavily used, especially for your future data structures, which are non-linear data structures, which which will be very, very hard to implement in programming without OOP. So, in order to understand it better, we can look at a real life analogy with computers. So, you can think of the computer as our ADT. It's a collection of electronics which stores information, gets input from its users, processes that data, and produces some form of output. And the computer is, well, now it's more abstract because we have different implementations of this computer, which are your desktops, your laptops, your smartphones, cell phones, and smart appliances. So in in a zoomed out view, each of these things do practically the same thing. They store information, they get input from us users, they process that data and produces some form of output. Although they have sort of different capabilities, the functionality almost sort of stays the same. So that's why we have different data structures because uh, a data structure may fully a data structure is a implementation of the abstract data type. So it could, as long as it accomplishes the functionality of the abstract data type, or it does the operations, it stores, or it has the same properties as the abstract data type, it's already an implementation. But how good the implementation is a different question. And that's why we actually have different data structures which almost function the same. So hopefully in this for this week we can look at different data structures that uh, that function as the same data type but have different performance metrics. So that's it for the introduction of the topics for the week. So let's get to it.